Question of the Week from the Naked Scientists.
Hello and welcome to Question of the Week from the Naked Scientists with me, Diana O'Carroll. This week, what does it take to blow a black hole?
Hello, I'm Beverly Johnson from Yorkshire, and my question is, why don't black holes explode once they lose enough mass? If it takes a very massive star collapsing to form a black hole and Hawking's radiation eats it away, then why doesn't it blow up after enough matter is eaten away?
Is there a critical point at which such an event could happen?
I'm Andrew Ponson. I'm a research fellow at the Kavli Institute for Cosmology at the University of Cambridge. The picture the question paints is that we have this black hole and Hawking radiation is making that black hole shrink slowly until the black hole gets to below some critical mass, and then suddenly it's not a black hole anymore and an explosion follows. That's not quite an accurate picture because actually there isn't a critical minimum mass for a black hole. It's more to do with the density of the matter. It's about packing matter in really tightly. And so it's even possible to have sort of microscopic black holes. So what actually happens is that a black hole never stops being a black hole. Once you've formed a black hole, that object is going to stay a black hole. But Hawking radiation does slowly eat away at the mass in a black hole. And in fact, the prediction is that a black hole should radiate faster and faster as it becomes smaller and smaller. So right at the end, as a black hole becomes tinier and tinier, we do expect there to be a sort of energetic pop at the very end of its life as the black hole shrinks away to nothing and emits a final burst of very intense radiation. So there is sort of a bit of an explosion right at the end, but that's not because it's reached a minimum mass. It's just because it's radiating away energy faster and faster.
So cosmologists do predict that there might be a small splurge of energy when the black hole becomes small enough, but this is due to the increasing speed at which it emits Hawking radiation. But then again, a black hole can get away with being microscopic and still be a black hole. On the forum, Sol Surfer said the final demise is a very small pop, only managing to reach solar luminosity for the last few nanoseconds, so one could only be detected if it was quite close. And Sifram said that black holes will only undergo this evaporation if they are the primordial sort and reach a Planck mass of 22 micrograms. That's pretty small. Next week, another problem of gravitational extremes.
Hi, I'm Matt from Norwich. I was wondering, what is the minimal gravitational force required to keep astronauts healthy during long space voyages? Would it take 1 full G, or could we get away with less?
Astronauts can suffer all sorts of problems in 0G, not least bone loss. So how little gravity can we get away with and stay healthy? Send your answers to chris@thenakedscientist.com. You can write on the forum at thenakedscientist.com/forum, or you can Facebook us or Twitter @nakedscientists.
Question of the Week is part of the Naked Scientists podcast and supported by the Wellcome Trust and UK Fast. Look us up online at nakedscientists.com.